Knowledge graphs. So this knowledge graph is a visual representation of information that shows the connections between different concepts, people, places, events and things. It's like a map of knowledge where the nodes represent entities and the lines connecting them represent the relations between those entities. So imagine a graph where nodes are like these puzzle pieces and the edges are how they fit together. So by piecing together these connections, you can create a comprehensive understanding of that specific subject or field. So these knowledge graphs are used in various applications such as search engines, recommendation system and natural language processing, which helps us to make sense of that complex data, uncover hidden patterns and drive discoveries in many domains from science to business. So to illustrate this knowledge graph with an example, let us consider a simple knowledge graph about famous people. So where the entities will be the people which are represented in the graph. For instance, you might have entities like Albert Einstein, Marie Curie, Galileo Galilei, like this. So these are entities. Next comes the relations. Now the relations between the entities are the connections that make up this graph. For example, you might have a relation between the Albert Einstein and Marie Curie, describing that they were both Nobel Prize winners in physics, and the relation can be was a Nobel Prize winner, where X is Albert Einstein, Y is Marie Curie. Third, the nodes and the edges. So in a graph, entities are represented as nodes, which are the circles or the squares, while relationships are represented by the edges or the lines which are connecting the nodes. So in our example, Albert Einstein and Marie Curie would be node and was a Nobel Prize winner would be the edge. Then comes the labeled edges. So to make the graph more informative, you can label the edges with the relations. So let's take the edge connecting Albert Einstein and Marie Curie would be labeled. So now imagine you have a large knowledge graph that includes many people, their relations and their attributes. And then the graph would enable you to find connections between the people, discover their effects and even predict relations that you didn't know before. Right? So here it is shown like this. Albert Einstein born in Germany, Albert Einstein son of Hermann Einstein. So like this. So here in the first thing, it's a factual triples in knowledge graph and these are the entities and relationships. So entity will be the theory of relativity and the relation will be proposed by. So this way we can understand the knowledge graph. So let's understand how it works. So the methodology of knowledge graph involves organizing information in a way that highlights the relations between entities. So first you will have to identify the entities. Start by identifying the key concepts, people, place, events or things that you want to include in your knowledge graph and these are the nodes. Then determine the relations. So for each entity, identify that connection or relation that exists between them. And these relations are the edges in the graph. For example, if your entities are actors and movies, so relation might include acted in, directed by, produced, like this. Then comes assign properties. So properties or attributes define specific characteristic of that entity. So you can assign relevant properties to each node in your graph. For example, actor's property might be their birth date, while a movie's property could be its release year. Then create the graph structure. So you can represent your entity using a graph structure where you can use visual tools such as flowchart or diagram to represent the nodes and edges, which will help you better understand the connections and visualize that information. Then populate the graph, where you can add data to your graph by filling in the nodes and edges with the information that you have collected. Then explore the knowledge graph. So where you can use the knowledge graph to explore the connections and relations between entities, and you can traverse the graph starting it with specific entity, following the edges to discover concepts which will help you gain insight and identify patterns in your data. So these knowledge graphs are dynamic and can be continuously updated as the new information comes in. So let's discuss the benefits of knowledge graph. The first benefit is data integration. So bringing data from different sources into a single unified form makes it easier to compare and analyze information. Then relationship discovery. So explicitly representing and analyzing relations between entities leads to new insights, connections and patterns. Then context aware insights, so which enables the creation of personalized recommendations, tailored views and contextualized search results. Then automation tasks such as data entry, fact checking, information retrieval, which saves the time, reducing errors and increasing efficiency. Then improved decision making and expertise consolidation. And finally, advanced NLP and machine learning. So where it can be used for understanding natural language queries, extracting relations from text and answering questions. Then semantic search, where it can be used to search for information using natural language queries that capture the relations between entities. Then predictive analysis, where the models leverage the relations between entities to forecast future trends, behaviors, or outcomes. Then intelligent system, where it provides a foundational layer of knowledge for building intelligent systems such as chatbots, virtual assistant, and expert system. Well, these benefits arise from the ability of knowledge graph to represent and analyze relations between entities, which makes them easier to understand, analyze, and automate the task. Then next, discuss the limitations of knowledge graph. So they have certain limitations. First is the incomplete data. So knowledge graphs are only as good as the data they are built on. So incomplete or biased data can lead to inaccuracies and misleading information, which can create graphs or the gaps in the graphs. Then data quality. So this poor data quality such as inconsistency, errors or duplicate information can affect the accuracy and reliability of knowledge graph. Then heterogeneous data. So bringing together data from diverse sources can be challenging, and the formats, vocabularies and ontologies which are used by different sources may not align, which can make it difficult to integrate and compare data. Then time sensitivity, expensive to build and maintain this, and then limited understanding of unstructured data. And then algorithm biases, so where knowledge graphs can unintentionally amplify biases present in the data which is used to build them. So it's essential to be aware of this potential bias and to monitor the graphs. Then limited expressibility, semantic gaps, where it can be difficult to find the right vocab or relations to represent some concepts effectively. Then performance challenges. So this large-scale knowledge graphs can be computationally expensive to query and analyze, requiring specialized hardware and efficient algorithms. Then what are the applications of knowledge graphs? So they can be used as a search engine. So Google, Bing and other search engines, they also use knowledge graph to provide more relevant and informative search results. So by understanding the relations between entities, search engines can provide answers to complex queries and display contextual information in the form of knowledge banners or feature snippets. Then recommender system. So the online platforms such as Amazon, Netflix, Spotify, they all use knowledge graph to recommend products, movies or songs based on the user preference and past interaction. Then natural language processing, where it can be used to perform tasks such as named entity recognition, question answer, sentiment analysis. Then semantic web, so where it can be used to understand the meaning of information and to make connections between different sources of data. Then business intelligence, where it can be used for consumer behavior, financial transaction or supply chain logistics. Then in the biomedical research, where it can be used to model that complex relations between the genes, proteins, disease and drugs, which allows the researchers to better understand the mechanism of disease and to identify the potential drug targets and to design that personalized treatment. Then knowledge management, so where it can be used in various domains like academia, government and industry. Then artificial intelligence, where it can be used to make decisions, answer questions and learn from various information. Then social networks, so social networks such as Facebook and Twitter use knowledge graphs to understand the relations between the users, groups and content, which allows them to create the personalized news feeds, targeted advertisements and insights into the user behavior. And finally, semantic search. So these knowledge graphs are used to improve that semantic search capability, which enables the users to perform queries that are more natural. So these are just an examples of many applications of the knowledge graph. The ability to represent and analyze that relations between the entities makes knowledge graph a powerful tool to understand complex information and drive insights across various domains and industry. Thank you.